Hi guys, welcome to another video. So today we'll be solving this question called longest common substring. It is very similar to the question that we have solved previously called longest common subsequence. There is a bit difference, but idea behind is very similar. Let's just look into it and hopefully we'll be able to solve. Okay, so here you are given two string A, string B. So let's just copy and we'll just paste over here. Okay, so we are given this S1 and S2. So what we have to do, we have to find a longest common substring. So you might be wondering, what is the difference in both of the question? Both of the question like almost looks very similar. What is the difference? So differences in longest common subsequence, if you are doing this, so you would have chosen the digits or the characters that are not even repeatedly like in sequence. Here, if it was the longest common subsequence question, then it would have been A. We can find A both place, and then this is D, na? Okay, this is D. C both places. So 1 plus 1, 2. Even like C is not directly after B, like here AC. Here we are not having B same, but in subsequence it would have counted. Again G over here and H over here. Okay, so if this was the longest subsequence problem, so the solution would have been, answer would have been 4. But here the case is not same. Here we are solving LCS longest common what is sorry, longest common substring. Okay, we have to identify a substring which is like the size is maximum in this scenario. Here are we having some repetitive, so let's see the here the length is 4. In this case CDGH, let's see, so continuous looping CDGH. Here you can see this is the maximum possible length where the continuous characters are continuously same in both of the strings. So let's see how do we solve this question. Okay, how do we start? We'll create a backtracking tree and then probably A. This is string 1, this is string 2. So we'll try to match if string 1 is it matching string 2. So at this point it is matching. So we'll return plus 1 and followed by next string. So next value. Here it will be B. So it will be 1 plus B and here it will be 1 plus C. So here it is not matching and it will cancel out. Okay, and till here we will have a max value and we'll write down the max value from minus infinity. We will initialize initially with minus infinity and then when we will overwrite with it with this positive maximum number. You can also initialize with 0 as well because the least minimum value can be 0 only. We can't go below that. So yeah, we can do that. Here we can initialize once after comparing we can do like max equals to 1. Again when you go to C na, so in here on one side C is having, on one side again C is having, so here it will go to 1 plus what you say D. Here also it will go to 1 plus D. Again 1 plus D will go into 2 plus whatever it is, 2 plus g. Here it will go 2 plus again g, and then similarly it will go, and thus we'll be able to solve this question. Okay, so let's just write down the code or logic, and that will make it more clearer. So variables, like we solved our most of the question here, variable will be n1 and n2. N1 will be length of s1, and n2 will be length of s2. Okay, so when length of n1, uh, let's just change the color. If length of s1, you can say if n1 equals to 0 or n2 equals to 0, in this scenario what will happen? It should return 0. Okay, it should return 0 because in that case, if either of them is 0, we don't have anything to compare, and thus will return 0 also. uh, okay, so what will be the main comparison scenario? We'll modify this more, but we'll look into the main comparison scenario. So if s1 n1, okay, equals to s2, this will be minus 1 cause it's like one base indexing, and we are considering 0 bits indexing, so that's why we are subtracting 1. So if uh, the character is same, like here a is matching, what we are doing is we are doing 1 plus and then recursively calling the next value. So let's say the function name is solve. Here we'll do s1, s2, n1, n2. Okay, we can do this. And what if the value is not equal to 0? So at any point when the value is not equals to 0, this will initialize the this will like break the what you say branch and set the value to 0. So we can write here or or s1 and 1 minus 1 not equals to s2 and 2 minus 1. If this will be there, and then we can return 0. So this will be like our base code logic. Apart from that, what we'll be doing, this will like compare only if we start at the right place, it will give you, it won't give you the maximum one. It will give you uh, what you say, at every point it will give you the most repetitive from that place. So let's see what I mean to say. Okay, so if you start from A, it will this code will execute until it finds that there is no more repetition in both. So at that point it will return automatically. So to get the final value, what you have to do is you have to execute for every element and then call this function. And once this function is called, you'll compare every time and then return value and replace it with the maximum value wherever you find. So for that, you have to do for I in range 1 comma n1 plus 1, for j in range 1 comma n2 plus 1. Here we are having I and jth value. So ith and jth value will represent the uh, like string A, string B, length. So index they will represent, and this you can call this function name was solve s1 s2 n1 n2. Okay, so here you can call solve, and then s1 s2 I comma j, and it will return some value. Well, and then you can say max equals to 0 at the starting, and max equals to max of, like max num, you can say max of max num, comma, then the value, and at the end variant return the value. Okay, so let's hand over to the code. Okay, so here we are comparing the base case as we discussed, and if everything goes well, we'll check the next value. Okay, and then similarly here we are looping, and then for every value we are executing this LCS function. Here we are doing the memorization, so we don't have to like if it is already there, it will store it. Just we are storing. This is useless. We are not even returning it. We are not even returning it. Okay, so this will work fine. Hope so. Yep, this is working fine. Daily we are getting. Okay, but this is the solution. Thank you.